Hey everyone. Today we're diving into procedural generation. This is a powerful technique in game development, and we'll be using Unreal's blueprints to bring it to life. So whether you're new to procedural content or just want to brush up on the basics, then this video is for you. Let's break down some core concepts, how they work in Unreal, and how you can start creating your own procedural worlds using blueprints. Let's go over what procedural generation actually is. In simple terms, procedural generation is the process of creating things with a procedure, like an algorithm, rather than manually creating them. Think of it as using a set of rules to generate things like terrain, dungeons, loot, and other things in the game. Now, Minecraft and No Man's Sky are great examples of what procedural generation can do. Now, procedural generation is an incredibly powerful tool because it allows you to create large, unique worlds without having to manually design every detail. And using Unreal Engine's blueprints, you can easily get started with procedural generation even if you don't have previous programming experience. Now let's break down the core concepts. The first is randomness. In procedural generation, random values are key to generating variation. So for example, a random number can help you decide the height of a mountain, the position of an object, or the layout of a dungeon. But randomness alone doesn't always work if you want to ensure the same outcome every time. That's where seed values come in. A seed is a number that's fed into the random generation process. By using the same seed, you can create the same results. Now, this is helpful in games so that players can always have the same experience when using the same seed. Now, computers generate random values in a sequence of predetermined values. It's generally impossible to predict what the next random value in the sequence is. But using a seed, we can tell the computer where to start in the sequence of random values. That way, we can get the same values each time we ask the computer for random values using that seed. Let's jump into Unreal and Blueprints to see how we can initially start using basic procedural generation. For this, we'll create a procedural terrain generator where we'll place static meshes throughout the world to create a terrain. Now, this is great as an intro example. We'll go over some basic blueprinting and how to use random values and seeds in Unreal Engine. Now, first, let's create a new map. I'll go up here to File, New Level. We'll create a basic level. This is what we'll use to create our terrain in. I'm going to raise up the player, start, and delete the ground since we'll be making our own. Then the player can fall onto whatever terrain we've made. Let me save this, just call it new map. Now in here, we'll go to our blueprints folder, create a new class of type actor. So this is the base class in Unreal. Here we'll call it BP terrain gen. Can open up our terrain generator blueprint. And let's look at the event graph in here. Now we'll only look at using the begin play for now. Let's delete these other events. Now in begin play, we want to generate all of the different parts of the world. So let me just start creating some comments and we can work through how we're going to generate this terrain at the beginning of the game. Our overall goal is to generate terrain. All right, let's put that at the end over here. Now, how do we generate terrain? What do we need to do in there? One of the things we need to do is to determine the locations. So like where are we going to actually put the terrain? Bring that up near the front. We can do determining where we're going to put it first or near the beginning of our process. We also need a way to spawn in our static meshes. And then generate the terrain, say, is our overall process for this. So let's look at just determining our locations and then putting static meshes at those locations. Let's go back to our map. So here our terrain, what we're going to try to do, let me drag in the level prototype meshes, there's some cubes in here. Let's try using these cubes to create our world. Let me drag in this cube, reset its position at 0, 0. So what we want to try to do is create a cube at this position 0, 0. And we'll go through and create more cubes along the world here to create a terrain. And each cube we can then adjust the height. So we'll end up with some sort of terrain that has these like jagged cubes all over the world. Now here, if you were to create a full world with this, you would want to create a custom mesh using blueprints rather than creating a bunch of instances of these cubes, since there's a lot of cube that's hidden away from the camera, but the computer is still working to create this information down here. So just keep that in mind in the future. If you want to create a full game using procedural generation, you'll need to look at optimization techniques. But for here, we're going to focus on using procedural generation to lay out this world. So let me delete these cubes. Go back to our terrain generator. Now in here, we can have a determine locations step. So for the locations that we want to put it at, all those cubes are on a grid. So we can say we put a cube at the position 0, the position 100, the position 200, 300, and so on. And we'll want some sort of maximum number of cubes in one distance. So we need some width and a height. So we'll go to our variables. Let's create a width. And this can be an integer as our width number of cubes and our height. Or to keep it, let's keep it a little clearer on what width and height are. Let's do x length and y length. And so that will be the overall length in those directions, in our x and y directions, with z being upwards. Now with these, we can look at using these x and y lengths to help determine where we're going to put cubes at. One way we can do this is by using for loops. So let me right click here and I'll type in for loop. So the for loop will iterate through from a starting index to an ending index. It'll perform whatever we put in the loop body over and over the set number of times. So here, if we drag in our x length, now we're going to loop, and here would be do something from our loop. We do that something from 0 to our x length. So here our array starts at 0, so we'll do 0, 1, 2, 3, 4. But since we're counting 0, that means we're using an extra index compared to our x length. So from our x length, we can use a -1 and compile and save that. And we can test out to show that this -1 is giving us our proper last index. Let's do our x length over here on the right, set our default to 5. So we want to do this for loop 5 times. We'll connect our for loop to our begin play. And from our loop body, we can print. This will allow us to print to the screen and print out our index so we can see what index is being printed. So we'll print out our indices here. Now each index, what we're expecting to see is print out 0 first, and then 1, 2, 3, 4, and that's an overall number of 5 things as depicted by our x length. Hit play. Nothing happens because we have not put this in our world yet. So let's go to our new map. Open up our blueprints and drag our terrain generator into the world, and I'll reset its position to 0. So now when we hit play, the terrain generator will actually be in the world, and we'll print out 0, 1, 2, 3, 4. That's our 5 things here. So within this, let's say instead of printing something out, we can spawn. So spawn actor from class in our loop body. Now here we can have some class that we put out into the world. Let's go ahead and make a new class that can include the cubes that we want to put into the world. So in our content browser, we'll add a new actor and we'll call it BP cube. We'll open up our cube. And now all this cube needs to do is have some visuals to it. So we'll add a new, let's add a new static mesh. Now in here, we can have any static mesh we want for this static mesh, right? So there's all sorts of different meshes already in here, but let's go back to our level prototyping cube and we'll use that as our example. We'll compile and save that. We can close the cube for now and go back to our terrain generator. Now in here, in this class we want to spawn, let's search for cube, use our BP cube. And we need to tell this spawn node where to place that cube. So we can drag off of this spawn transform and make a new transform for it. And we have the options to change location, rotation, and scale. Let's leave our rotation and scale the same for every thing we place down, and we will then change the location. So I could drag off of this location and make a vector. This will allow us to set its X, Y, and Z positions in the world. Now here, since we're iterating through X, let's plug our index into X. And now we'll place this cube 5 times at positions 1, 2, 3, 4, and 5. Let me compile and save. Open up our map, hit play. You see we landed on a cube. Here, to exit out of the play mode, I can hit Shift F1, and now I get my mouse back. And there's a option up here as well for if you hit F8 instead, or come up and click it. Now I can move around the editor as the game's playing. We could see all our cubes are overlaid with one another, since their positions are at 1, 2, 3, 4, 5, which are all right here near the origin. Our cube itself has, let's see, let's pull it up. It has a width of 100 along each direction as its base size. So in our terrain generator, we can take our index and multiply it by that size we want to use. In this case, it'll be a 100. But let's right click on this and we can promote it to a variable and call it world scale. So that allows us to convert from these indices that are 0, 1, 2, 3, 4 into an actual scale for the world. And we'll compile this and set the default value to 100. So then our first cube that we're placing has an index of 0. Multiply that by 100, we still get 0, so it'll be placed at the origin. For index 1, then we'll multiply it, get 100, so we'll place that at 100, then the next at 200, 300, and so on. Let's hit play. And we can see now our cubes are offset from one another, so we've started placing our cubes along that one direction. We can change our X length. Let's do this 100 times. So now it'll place a total of 100 cubes into the world. Here we go. Go back to our terrain gen. So this is creating the cubes on our X direction, but we also want to do it in our Y direction. So here we can use another for loop. I will copy and paste this for loop. And we can connect that to our begin play. This time we want to do y length -1 as our final index. Now in this, we can perform our generation of this line for every single y value. So we're generating this line of x cubes, and now we can do that y number of times for our y direction. So if we plug that into our loop body, we'll loop over this loop many times with new y values. Now here, if I don't do anything else, we won't see any change yet in the world. Let me hit play. And nothing happened. Because y length, our default value is still 0, so we did that 0 times. So let me set our default y to 10 and our default x. Let me bring this back down. Let's do it to 3. Now let's go back to our world and test it. So here, let me hit F8 and go back out. We actually have, if we look over in the inspector or in the outliner, we have many cubes here, but they're all overlaid. So we are creating our 3 cubes for our x over and over, but we're not changing its y position yet because we don't change our actual set y value. So we can, again, use our world scale to convert our y index into our y position for our cubes. So I'll copy and paste the world scale and multiplication section, connect that to our first index. And now this will be our new y value. We'll compile and save, go to our map, hit play. There, now we're getting our 10 cubes by 3 cubes. So we're iterating over our y length and our x length. Let's move this up to 10, so we'll be generating 10 by 10 grid of cubes. Perfect. Now let's look at changing their height. So here we've changed our x and y values, but we could also change the z value. Move these comments. Clean it up a bit. Now for our z value, we can start to add in some random noise using different procedural generation techniques. So to start, let's type in random. Let's do a random float in range. So this will get us a random float value in a certain range and connect that to our z. Right now our range is 0 to 0. Let's do 0 to 200. So now every single cube that we spawn will have a random height from 0 to 100. Let's see what that looks like. There we go. Now we have random heights for all of these. But each time, now if I play it again, our random generation is different every single time. So here, we're just using our random values from the computer, but we can also use a seed value to make sure that we generate the same thing every single time. So here, instead of using our random float in range, we can say random float in range from stream. So in Unreal Engine, the stream is our stream of random values. Let's plug this in and replace our old one. And we'll again do from 0 to 200. So our stream is this stream of random values, and we can make it with an initial seed value. So here our seed is 0. So we should be getting the same exact world generation or the same exact z height value because we're using the same seed. Now here we're getting our making a random stream inside of these for loops. So for every time we iterate through, we're changing our stream. So this will still not give us the correct result, and it'll actually give every single cube in the world the same exact position. Since we're telling the computer, use this same stream in the same seed for every single cube. So if we hit play, we should see every single cube is at the same exact height since we're using the same stream for all of them. So what we could do to get away from this is to move our stream outside of our for loop. So let me drag back our begin play. Now we can take our make random stream and promote it to a variable. And let's call this local stream. So this is the stream of random values we're using in our sequence of code here. Now let's plug in our local stream later. Now we're only creating the stream at the beginning and not changing it to be the same exact thing for every single cube. So now we have our stream, and as we get random values, now we'll continue down that stream to get the next value. So here with our seed of 0, now we should be back to generating our random heights for every cube. But if I play it again, we should see that everything's at the same height. So let's try to keep an eye on this back right one, and it's how it's lifted up above these others. If I hit play again, here we go. It looks like it's the same. Play again. Yeah, so now we're getting the same exact world generation using this seed. Now we can go back to this terrain generation. If we drag off of the initial seed, we can promote it to a variable. Let's just call this seed. So now we can choose what seed we use to create the world. So if you were to load in the game, you could also load in the seed and apply the seed in this generation process to make sure that the player gets the same exact world that they had when they last played. Show this seed changing. Let's make it instance editable and private. So instance editable will allow us to change it in the world, and private means that no other blueprints can change it. Let's go back to the map. In our terrain generator, now we have the seed value. So we can increase it to 12 and play it. And if we close and play it again, we'll get the same thing. And if I change this to 7 and play it, now we'll get a different world with our seed 7. And again, you can make this any value we want, 88. We get a world here. Let's go to our terrain generation. Let's play around with some of these values to see if we could get nicer looking terrain. So here for our max, we're changing the height by a maximum of 200. Let's decrease that. Let's do 50. And since every cube is 100 tall, that means none of them will be all the way above other cubes. So there will be no gaps between the cubes in the world. Let's see how this looks. There we go. It's looking a bit better. And we can also create more cubes in the world. So let's just bring this up to 100 and 100. So now this terrain, we're just purely using random values. So it won't make mountains or hills or rivers or anything. We can create further procedural generation rules to make those shapes. But right now our rule is to create random heights. So let's hit play. This will take a while since I'm generating a very large number of static meshes all at once. So you could feel free to decrease this value. Here we're seeing the limits of using static meshes to create a world, since it has to also, the computer has to generate all of this information that we're not even seeing. And inside every cube, we have all these walls that we're not seeing, but the computer is still having to generate all of that. So if we were to use this in a game, we'd want to only create the surface level of this map, which we could do by creating procedural meshes instead of using static meshes at the beginning of the game. We'll cover procedural meshes in a future video. So there you have it, a quick overview of procedural generation and how to get started using blueprints in Unreal Engine. The possibilities of this are endless, so you can make things like landscapes, levels, dungeons, or even NPCs themselves. If you found this video helpful, please hit the like button and subscribe to the channel for more Unreal Engine tutorials. I'll be continuing this series on procedural generation, but if you have questions or have ideas for future videos, please let me know. And otherwise, thank you for watching, and I'll see you in the next one.